Okay, so if people could download from the Moodle site those two files that I posted in the data examples, datesuniform.tab and dates.tab, and put them in the folder whence you will be starting Scala, that will be good because it will allow us to load them in here. Okay, so there's a couple of sort of cleanup topics that I want to hit before next time we dive into some ongoing reading from the book, which is going to occupy us for most of the semester. I'm again trying to communicate some basics so that we can then use Scala with big data in a more fulsome way, and so that the book will be less overwhelming from the side of learning Scala. There'll be enough to learn from the book in terms of principles of functional programming for the first book that will really occupy you and make you think. And I don't want you to be distracted by at the same time trying to learn Scala on top of it. I want you to be clear about the Scala constructs, if at all possible, while you're learning the functional programming concepts, hence these lectures. Okay, so ladies and gentlemen, we are, to that end, going to talk about a number of concepts that we didn't discuss last time. But before I do that, I did want to give a nod to the exercise, the take-home exercise, on which we had worked. And I was hoping for a bit of comment from you folks on that exercise so that you could tell me how you approach the problem. So this problem of creating the integrator function, how did you approach that? How did you, broadly speaking, how did you create an answer to that? How did you? Let's start simple. How did you create a curried function?
Just three sets of brackets.
Indeed, successive parameter lists, right?
Yeah.
And it's important to note that in Scala, successive parameter lists are not only supported, but you not only can distinguish things at the level of a parameter list, but an entire parameter list consists of implicit parameters that are taken without even explicitly providing that list. So the list itself is an important context. It's not merely that if you provide implicits, you don't have to put in anything in that list, but you still have to show begin paren, end paren. You can omit the whole list, okay? So when it comes to discussing implicits later in the semester, you should realize that those lists, which I will, just remind you, right? This is like curried, so def, curried add, remember this, right? Where we had A and B, and this is equal to A plus B, right? This curried list, you can put several parameters in any one of these, right? And all those parameters could be declared implicit. Like if this one were declared implicit, this entire list, we could omit it if it can find the requisite information elsewhere. We don't even have to put the begin paren, end paren. It can just fill in those things for us. So we'll come back to that later. Just be aware that these parameter lists as a whole, like an entire parameter list, is kind of a unit that can be, in some cases, elided. Yeah.
So we separate
left out
parameters when we want to have curried functions.
Correct.
I mean,
correct.
In that sense, could we put both of them in one parenthesis, like?
Yeah. Let's do the compare
fact,
these two. It's a great question.
You kind of needed to do that in this case because it takes both inputs and you need them both at the same time.
Right.
So you put them both inside.
For which one?
Well, the integrator, you need to know the beginning and end point.
Correct, but you could specify the function earlier.
Yeah. So
Yeah.
so the way, I mean, at least the
But
way
the
I
beginning
do it,
and end
there's-
point are
there's a
taken
function,
together.
Then there's
That's right.
delta, and
That's
then,
right.
and then you take it and
Exactly.
beginning and end at the same time in
Correct.
one parameter set because you can't. It doesn't make sense to give it only one.
Right.
It might for your uses, but for us we didn't. So. You could.
You could.
Because you could calculate the
Exactly.
initial value.
Yeah,
Exactly.
That's right.
And
You
I
have
actually,
to.
I contemplated whether to give that to you or to use them together, because it could be useful, right? You specify the initial value, and then you say, well, integrate it here to this point, and integrate it here to this point. That might be a common use case.
Yeah.
And if it was a common use case, you'd break those up into different parameter lists. Scott's exactly right. And so,
You're arguing in advance of your topics.
yeah.
Do you really want to talk about use cases and how Scala assists with those?
Yes, because it's use cases that drive these. Like when I
Yes.
try to consider whether or not I want to have one parameter list or two, I'm going to be thinking, how am I actually going to use this? Is it a very common thing that I might have some of the information early on, could specify it up front, and then other of the information will be changing. You know, sometimes I do one thing for the other information, sometimes another, but always with that same first information. If so, creating a staged computation is really useful.
So as an example, if I want to calculate a time persistent variable in a simulation
Yeah,
model,
yeah.
if I know the starting time, for example, 0,
Right.
and when I calculate it to any given point, I might curry.
That's right.
integration.
Or if you're taking a dot product of one known vector, a vector that's known up front, with a whole series of subsequent vectors, you might create a curried function. And in fact, there you could even take advantage of the fact that the vector you know early might have some 0 elements. You can just ignore those elements of the other vector, etc. So this staging of computation does have performance limitations when it's analyzed by a proper compiler, and the point is that often we do think when I decide whether or not to curry, I'm thinking of the use cases and whether or not to break it up. Okay, so let's talk about this curried add and non-curried add. So non-curried add here, you have to provide both pieces of information together, right? Obviously, this is a contrived example, but it's going to show the principle. Whereas if I have a curried add, there it's, I can provide part of the information. Now, the key thing is, again, that if I just provide 2, that's a partially applied function. If I want to get back a function from it, I do this, right? Val, add, increment by 2, right? Increment by 2. So I put this underbar after it, and now it may be a common use case that now I want to increment things by whatever, this is. And sometimes I want to add it to 2, and sometimes I want to add to 6 or whatever, right? And may use it over and over again. This is very common, and in the software I write, it's extremely common that I might know some things up front, and then some things I only know later. And instead of dragging around the things I know up front, it's kind of nice to have something that just remembers them for me and applies it later. Okay, so this is the curried, and the point is that we can actually, in some cases, have one whole set of parameters be specified implicitly, in which case we only have to specify the latter one, and we're done. Okay, we're going to see that quite a bit with Spark, actually. Okay.
But one
Yes.
other point here is that a non-curried function cannot
Yes.
be partially applied, which means you can't actually
Correct.
create
Well-
increment by 2 with a non-curried add function, can you?
No, you can't. Right. Correct.
Just
Correct.
Very basic, but I wanted to-
That's exactly right. Yeah, I mean, at a technical level, it can be applied.
You can
It-
carry it by
you could-
dot carry.
You sorry?
You can still apply a non-partially applied function. But the trick thing is that
Well, what you could do is do this. I mean, you could do function, val, function, trick. I don't know how to do it. Fake curry. Yeah, exactly. This is like I don't know what dish it would be, but
Could you drag it up?
it would be a masala or something like that. This, here, this could be something like I think actually this might actually. X fn fake. And
Good to go.
I gotta
Yeah.
say and. Sorry. What? Okay.
I think you have it.
Oh.
That's a plot,
Okay, so what's going on here?
Can you drag it up so we
Semicolon
can
instead
see
of
the
colon.
mat?
Did I do it?
No,
Oh.
that's right.
X as int, I believe, is a semicolon. Oh no, it's at the or it's expecting one.
No.
No, no, because this is semi.
No, expect a semicolon at the end of the
Okay,
line.
okay, so what's going on here? Why is it unhappy with that? That's really an interesting. It's an interesting unhappiness. Okay, first of all, let's get rid of this just to simplify the situation. Okay, so why is it unhappy? First,
There's
let's
2 errors.
non-curried add. It could be there's 2 errors. I just want to do a sanity check. Yeah, happy. Okay, so why is it that it is unhappy?
Shouldn't be called by name or something.
No. This should be able to be a function. Okay, so let's try this. Okay, yeah. So there's something more basic here going on.
What
It
is it?
It wants the a close paren after the non-curried add function, like immediately after.
You have to
Yeah.
put x int in brackets.
Sorry.
You have to put x int in brackets.
It could be. That sounds to me plausible. It's probably a parsing error. Yeah, happy. Okay, Krugerian triumph. Well,
Good little nitpicking. That's what I do.
yeah. So happy. Okay, let's go back to this. Okay, that's a little bit of Scala persnicketyness. Okay, and I think it's nice. This is a fake curry thing, right? This takes the value and then just passes it to this. And so this is how you could render that into a staged computation with additional mechanism.
The nice thing with that is you don't have to choose the order of
That's
parameters
true.
when you're creating your function.
That
This
is
is
true.
more general.
This is true. Yeah, I don't disagree.
Huh.
Okay. Okay. Great. Okay. So with the curried add, we can provide part of the information. Okay. So then the question was, ladies and gentlemen, when you were doing this function to do the integration, so val or def my numerical integrator. First, you took in a function, right? It was a
Use
unary
that.
function.
Yep. That chair is broken.
Oh, okay.
Yeah, I would bring one from outside.
Okay. What's the nature of the dysfunction?
It's cracked down the middle, and so it pinches when you sit down on it.
Yeah.
The thing comes apart, and when you lift up a little bit, it pinches you in the left.
Okay, that doesn't sound pleasant.
Yeah, you can see right here. This.
Yeah. Oh yeah.
So when you sit down on it, and
Oh,
then when you
gosh.
get up, it pinches you.
Okay. Yeah. Okay. Thanks. Okay. So, ladies and gentlemen, first we had to take in a unary function, right? Which is an int to an int, right? Right?
Double.
Oh, double. Thank you. It wasn't an int. I'm slow this morning. It was a double. Yeah.
Toronto will do that too.
Okay. And then we took in a dx, right? A dx, and it's a separate value. What am I doing? Okay, and then we took in an initial value and a final value, right?
Mhm.
X initial, I can't remember what I told you to
Start.
call them. X start, thank you. X start, double, X finish, double. Is that right?
X end, but that's fine.
X end, okay, great. Okay, so what needs to happen now?
No.
Yeah, what needs to happen? Oh,
Apparently.
no, what needs to happen here? Okay, so that's a great start.
Yeah.
Look at that, what a fine thing.
Do you have to go equals after that?
Okay, but yes, you should do equals, you're right, okay, boom, hey.
Just do a close bracket and let it air out on you.
Yeah,
One
or I could just do two. Okay, that's interesting. Can have declared but undefined members only classes. Kind of okay. I don't know what's going on there with its. unhappiness. Okay. That it wasn't defined. I think that's what it was saying. Fine. Okay. So what does this need to do?
Bracket, like.
Okay. You want to do a curly?
Mhm.
Okay. Okay.
And
Do
then-
do we need a curly? Can we do it without a curly?
I think we can do.
I
Okay.
did it in a single line.
Yeah. Yeah.
But
Exactly.
it's kind of a long
I
line.
did it with 2 lines.
Okay. So how about a long line? Not,
The struggle I had with the long line was making sure that accounting for the fact that delta x might not fit particularly.
yeah.
within-
Let's ignore that uncomfortable fact right now. So what would you need to do?
You need to have a vector here. Like
You
Yeah,
need to have a
make it vector.
vector, and the vector is going to consist of what? From
Initial
where's it going to
point.
start?
X
From the
star.
start to
until.
until
xn minus delta x.
No, we can say until and then.
you could say
Say
and
insert
divided
from
by
X,
the-
yeah.
By
dx.
by the dx.
yeah,
or-
yeah. So you can do it that way. So this is what I wanted to get to. I'm just going to do this for now. Obviously, that's not our integrator, or else the world would fall apart. Okay, so ladies and gentlemen, suppose we wanted, this is what I wanted to get to. Suppose we wanted to get a vector of successively larger values, starting at x start and getting successively larger
Mhm.
to x end minus dx. How could we do that? Let's simplify our life. Suppose we wanted to go from 0 to 1 in steps of 0.2. Give me a couple ways to do that in Scala.
0 to 1 by 0.2. 0.0 to 1.0 by 0.2.
I don't think.
Yeah,
that-
that
Yeah, it
works.
works.
Yeah,
That's what I did.
yeah,
Are you serious?
yeah.
Do it.
Huh?
So you have to go 0.0 because it's
By-
double
Uh,
instead of in.
Okay.
Or you can just write 0. So,
Are you serious?
have it
Yeah.
already after that.
Yeah.
Okay, by
0.2.
0.2. Oh, sweet.
The downside is you get these weird rounding errors.
You can do 2 ways.
Okay, yeah,
ranges.
because I'm used to dealing with regular ranges, not double ranges. That's
Yeah, I
really
know it works.
that is sweet.
Yeah, that's what I did.
Okay. Okay, a second
And if you use
Krugerian
until,
triumph.
If you go
Um,
1.1,
if
it'll
you go
still.
with until, it goes just
Yeah,
up
to just yeah
before.
to sorry
No,
to
not
to
to.
until.
Oh, I didn't do until. That's a good idea.
Yeah.
It goes till just
Sweet.
before.
Yeah.
That's good. And then if you go dot last
Yeah,
or dot end,
yeah.
it tells you
This,
yeah. But if you go dot last,
yeah, it's the final one.
yeah.
Yeah. So this is kind of the limit of it. This
Yeah.
is kind of the last one
That's
in
right.
the sequence. Okay, so that's
Actually,
sweet.
until, that's a good idea.
That was the thing I wanted to concentrate on, and then what has to happen within this. So you showed me a better way than I was going to show you. I was
Okay.
going to show a couple ways to do this that I thought each were pretty good. What I didn't appreciate is numeric ranges. So that's
Couldn't you
Awesome.
couldn't you write a vector and then have it filled by a function?
Yes, you could. Although here I was thinking of mapping it. Yes, you could write a vector filled by a function, and there's basically a couple ways you could do that. One of them is with what's called tabulate.
Oh, okay.
Yeah, I didn't quite
Um,
get how that
So you could do vector, for example, of int dot tabulate, and this could have or vector of double tabulate, let's just say, and here tabulate will take a certain number of elements. If it's in 1D, it's just one element, and then it will apply a function to each of those elements, passing it the index. Okay, so
Oh, that's nice.
you'll give it a function which takes in an index I, okay, and then returns some function at the index. So it might be I times 0.1 or something like that, right? Oops, sorry.
You don't have to say double.
Did you have to say double?
you
No,
do that in the function.
this, okay, but double literal found, okay. Identifier, of course, you don't have to say double, of course, yes. What am I doing? Okay, identifier expected, but double literal found, okay. I think it's the whole, these parent things again. There we go, yeah. Okay, so that's a kind of sweet thing. So we could have done I times I, and there we'll create a value of successive things. That's one way to do it. Another way to do it is to say iterate over 10 things, and here with iterate you have to specify an initial value as well, and I think it's the first value here, and then basically it will successively apply a function to that thing. So here you would take in a double, for example, and you could add 0.1 to it, okay? D plus 0.1, something along those lines. Okay, so type mismatch, it says it's requiring, of course. I meant to do 0 there. So here, this is the first element, and then the second element will be the function applied to that previous element. So function applied to 0.0. The next one will be the function applied to the function applied to that next one. So each successive one has one more of these functions wrapped around it. In other words, the first is the initial element, the second is f of the initial element, the third is f of the initial element. So this could have been, for example, times 0.1, and now that's confusingly uninteresting because it's could all be 0, but we could do this, right? Here's 0.1, here's 0.01, here's 0.001, successive kind of multiples of that, right? Yeah.
Interesting.
Okay. So ladies and gentlemen, that is iterate. Yeah. And another one we can use is fill. And fill just evaluates the same expression. And that's not going to be very useful in this case because we need it to have some sort of memory of what's going on, in the sense of we need the next one to remember about the last one so it can be larger than it, or at least to know its order in the sequence. So a fill is not going to be that helpful here. So anyway, these are sweet things, and these exist for more than vectors. They exist for whole swag of collections, including streams and other good things. Okay, ladies and gentlemen. So having done that, I'm going to prefer the first solution, which was shared with me this morning, way up here. By the way, I'm going to be getting in the habit of every day taking the scripts from the day, hopefully cleaning them up a bit, maybe commenting them a little bit, getting rid of the things that led to mistakes, and sort of doing the, giving the final version of it, and putting that onto the site in addition to the video. So you'll have the scripts and then you'll have the video, okay? And hopefully that will add interest to things. And if you're puzzled about pieces of it, ask me, and I can put in more comments, about what's going on there. Okay. So what do we have to do here to complete this story? So we need to go from what to what? Instead of 0 to 1, we need to go from x start until x end by dx. Now again, I'm going to ignore the ugly fact that dx may not go evenly into this, okay, just because I want to get on to other things. And then what do we have to do at these points?
Mapping it to.
Okay, so we have to map, and what do we have to map?
Function.
Okay, so at each of these points we're going to compute fn unary, that's the function, applied to what?
Elements of the.
Okay, so applied to, you could just do underscore, because alternatively we could have done x double, gives this, but here we could just do underscore, and then what else do we have to put?
That's sum over it.
Sorry?
Summing over it.
Okay, we're going to have to sum over it, but don't we have to multiply by dx? Yeah. So something like this. Oops, dx. Yeah?
Yep.
And then what?
Reduce.
We could do a reduce, but
Some is also
some we can do.
works.
Yeah. Okay. Okay, and now, ladies and gentlemen, we have a nice little approximate integrator, and it's approximate particularly crudely because it avoids considering whether it goes evenly. But in my mind, that is every bit as beautiful as anything I could see in the Louvre.
If we don't use this,
And I
this
certainly
is
think
here.
it compares favorably to most modern art by a long shot.
So Dr. Osgood, if
yeah.
I wanted to create a numerical integrator to do system dynamics numerical
Yeah.
integration in Scala,
Yeah,
since I know that any given time step will be dx,
yeah,
that means I don't have to ask. Okay, I mean that's where curried functions become very useful because I know everything,
Right.
almost everything already.
Right.
So I can create a highly, parameterized implicitly
yeah,
function that only asks, well, what time are you evaluating this in?
right.
If I already know the time step, then I can just do everything else, right?
Yes, there's a lot you can do ahead of time based on that. And in fact, there's a whole area of compiler theory called stage computation where they actually, and there's a particular method called partial evaluation where you take the information you know up front and you actually do a lot of the work up front. And you just wait for the remaining information to do the little bit that you have to do then, or the
So
extra
basically,
bit.
you actually perform some of your calculations and
Totally.
functions at compilation time.
Correct.
Interesting.
Yeah, yeah,
Okay.
yeah. Or at a time where you just start the program, you load the program in, you do a bunch of the computations. Instead of performing dynamically every time through a loop, you've done them all well ahead of the loop. Yeah.
Right.
Yeah. Anyway, so ladies and gentlemen, that's our little sweet numerical integrator. Approximate. I didn't handle that little fly in the wall, the fly in the ointment, which has to do with this, the fact that dx doesn't go evenly into that. And what's that?
Adjustment of the x or
Well, so what you can do is you can figure out. This is fine, but you have to figure out basically how much is left over, and add that into the sum as well.
Well,
So doing it in 2 lines is nice.
Couldn't you also just as easily recompute dx? We could instead of viewing dx as this is what
As
I
a fixed thing,
this
absolutely.
Is, this is the upper
That's
bounds
right.
as to what my interval length.
And one of the things I contemplated was instead of specifying dx, just saying
Number.
a number of time steps during that or something like that, and that would have been another way to do it. Or you say dx is the upper bound, but we have the right to sort of adjust it slightly lower so that it fits evenly or what have you. Anyway,
Or simply just a drop right one.
drop.
One.
Oh,
And that would be discarding the last thing in that list.
okay, drop right. Good, but that's kind of what the until is doing here, right?
Yeah.
It's
But that still doesn't stop you from having. You still have to.
No, it's not exactly as in
Yeah.
saying.
Yeah,
It's
yeah.
after it has been
Yeah.
the list has been populated, you drop the
Right.
last one. So it's
Right.
kind of filling your purpose of ignoring the last one, and then you're recomputing what's the step left at the last point.
That's correct. Yeah, exactly. And basically, if it's 80% of a step, you'll add 80% of this value in for the last sort of component. Anyway, I think it's beautiful. I hope you see some glimpse of beauty in it. And I'd like to now go on to a couple additional topics. Okay, so that was. Any questions about this?
so you use the function inside the map with the argument.
Yeah.
Can we delete that? I mean, just use the name of the function.
No, because it will say, well, it's a function, but what do I apply it to? What do I apply it? And the key thing is you want it to be applied to the value that comes out of this successively, the successive values that come out of it. So it needs to be applied to one of them. If we had gone something like this, it would say, well, you're trying to multiply a function now times a value, a double, and I would expect that it would complain in the most bitter of fashions. It might.
Can you just
Sure. Do you want me to try?
Yeah, please.
Okay. So the problem is fn unary is not going to be defined. Let's do this. Fn test.
Oh, I got wait. Okay.
You got it?
Yeah.
Okay. Yeah. Alternatively, I mean, just to be clear, I want to make sure people aren't left out by this notation. Again, this is equivalent to what? How could I rewrite this in longer hand, but one where it'd be more evident?
X double
Yeah, and so we could do this instead, right? That's the same thing with that underbar. Underbar, unfortunately, is deeply overloaded in Scala. In certain places, it means certain things, and it's really unfortunate. Sometimes it means like throw away the argument. I'm ignoring it. Sometimes it means like turn this from a method into a function. Sometimes it means, use whatever's given to this as the element here as the thing to give. I'm personally uncomfortable with that overloading. I think it is confusing, and it also gets in the way of understanding it. I think sometimes it also was a practical thing that we sometimes are we would like to use it in both senses in the same expression. We want to use it sometimes to mean like throw away, sometimes to mean put in the value here, and you can't do that. So I'll readily admit Scala is imperfect as a language. I mean, I have some disagreements with it, but that's fine. I'm sure they have some disagreements with how I do it.
Specify the double after x is actually stricter than you specifying underbar, because underbar is ignoring the type in the sense of that.
Sure.
It's actually
Good call.
looser, strict.
It's looser.
Yeah, looser.
Yeah, it's not a loser, but it's
Alright.
looser. Yeah, that's a subtle thing. Sanxi. That will cause me problems for my life. Okay, so yeah, it's a looser thing. You're absolutely right. This is looser because we're not necessarily specifying that it has to be a double.
Yeah.
Good call. That's absolutely right.
And also avoid some trouble things when converting from int and double. You probably can just use number. There's a nice abstract class
Called number.
All the,
Yeah.
all the rest of them are
Yeah,
incorrect.
and in fact, in Scala, there's abstract classes for a lot of things. So there's a class even any value, which will allow you to have chars or doubles or ints or floats or characters or what have you. And then there's another one, any ref. Yeah. Anyway, okay, ladies and gentlemen, beauty. Okay, and